Hey everybody, our lesson today is on mixed numbers, part 5, adding mixed numbers with unlike denominators. And mixed numbers are numbers that have a whole number and a fraction. For example, 2 and 2/4 is a mixed number, plus 1 and 1/3. 1 and 1/3 is a mixed number also. The 2 and 2/4 you can see here, there's 2 wholes, and the 2/4 is right here. The green ones represent the 1 and the 1/3. Unlike denominators mean that the bottom number, which are called the denominators of the fraction, are different. In this case, you see the 4 in 2/4 and the 3 in 1/3 are different. Okay, our first step when we add mixed numbers is to add the fractions. And right away, we see that the 4 and the 3 are different, and that breaks the math rule. They must be the same. So our job is to make them the same. And how we do that is we use multiplication, and we are going to have to turn the fourths and the thirds into something that's common. And to do that, we use something called the least common denominator, where we're using multiples. So for example, multiples of 4 would be 4, 8, 12, and 16. I'll show you where I got those. Multiples of 4, 4, 8, 12, 16. It's always a good idea to memorize your multiplication facts. Multiples of our thirds, or our 3, would be 3, 6, 9, 12. I usually just do about 4 to get started. So here's 3, 3, 6, 9, 12. Least common. Common means same. We're looking for the same number in this top row as on the bottom row, which I see is going to be 12. So that's good. We have now found the 12ths. We're going to have to turn the fourths and the thirds into 12ths. How do we do that? We use multiplication. Okay, 4 times what number will equal 12? Well, I'll show you a trick. You can just go 1, 2, 3. And when you multiply fractions, remember to multiply both the top and bottom. 2 times 3 is 6, and 4 times 3 is 12. Same thing on the bottom. We're going to multiply. 3 times what number equals 12? 1, 2, 3, 4. Do both. 1 times 4 is 4. 3 times 4 is 12. Notice now that we have 12ths, and that means that we can add. So 6 12ths plus 4 12ths would be 10 12ths. Finally, we're going to add our whole numbers, which is 2 plus 1 would be 3. So our answer would be 3 and 10 12ths. Notice that we converted the fourths and the thirds into a common denominator, a common bottom number of 12ths, by using multiplication. And we did that by using multiples. When we add mixed numbers with unlike denominators, there's 3 rules you want to keep in mind. The bottom numbers, when you add fractions or subtract, have to be the same. If they are not the same, like we're dealing with in this lesson, your job is to make them the same. How do you do that? You use multiplication, and we're going to multiply and turn it into the least common denominator. In other words, we're going to do multiples of the bottom numbers. So 4 and 2 tenths plus 1 and 2 fifths. Right away, I see my tenths and my fifths. I am not allowed to add the fractions the way that they are. I can represent that 2 tenths plus our 2 fifths. So I'm going to make them the same by doing multiples. Multiples of 10 is just like you're counting by 10. 10, 20, 30, 40. Multiples of 5 are simply when you're counting by 5s. So let's write them up here. Just do a few. I usually do about 4. 10, 20, 30, 40 are your multiples of 10, right? Multiples of 5 would be 5, 10, 15, but I see my 10. I don't really have to go any further. I'm happy because now I know what I need. It's going to be 10s. Now we multiply. 10 times what number equals 10? That is easy. That's going to be 1. And you could just count 1. Do top and bottom. 2 times 1 is 2. And 10 times 1 is 10 for 2 tenths. Same thing on the bottom. 5 times what number equals 10? It's going to be 1, 2. 2 times 2 is 4. And 5 times 2 is 10. Notice now that our denominator is exactly the same, which meets rule 1 that the bottom number must be the same, and we are good to add. 2 tenths plus 4 tenths would be the 6 tenths. And finally, we would add 4 plus 1 is 5, and our answer would be 5 and 6 tenths. Showing it with the models, what did we do? The tenths that you see here stayed the same, and we just showed that mathematically by multiplying the 1, just to make sure that we had all our boxes checked here. The fifths is really what changed, and we just multiplied that by 2. We did 2 fifths equaled 4 tenths, and that would show how that works. Notice they're the same size, and we got a total of 1, 2, 3, 4, 5, 6 tenths. Let's try one more. Go ahead and pause it if you want and give it a try. We'll go ahead and solve it. Okay, 6 3/8 plus 2 1/4. I start with my fractions, and right away I see that the bottom numbers are not the same. And so by rule, we cannot, it would break rule 1, not the same. Rule 2 means we have to make them the same, and we're going to use our multiples. You say multiples of what? Multiples of 8 and multiples of 4. I'm going to show you on the multiplication chart. 8 would be 8, 16, 24, and 32, and 4 would be 4, 8, 12, and 16. Again, you really want to memorize your facts. Okay, multiples of 8. We said 8, 16, 24, 32. I just usually write 4. It's not a rule. Multiples of 4, 4, 8, and I'm see that I have my match. I'm going to stop there. So our job is to make these guys into 8s. This is easy. Remember we said we use multiplication. What times 8, or 8 times what number equals 8? That would be 1. We do top and bottom. 3 times 1 is 3, and 8 times 1 is 8. On the bottom, we're using multiplication. What number, 4 times what number equals 8? It's going to be 1, 2. Top and bottom. 1 times 2 is 2. 4 times 2 is 8. And now we are allowed to, meeting the first rule, that the bottom numbers must be the same. 3/8 plus 2/8 is equal to 5/8. And lastly, 6 plus 2 of our whole numbers would equal 8, and our answer is a mixed number of 8 and 5/8. In review, we did adding mixed numbers with unlike denominators today. We said that we start with our fractions. The bottom numbers must be the same. If they're not the same, we use our multiples, and we multiply both the top and bottom to find the least common denominators. And then we add our fractions and add our whole numbers. All right, thanks everybody.